In this final video on linear regression, I wanted to do some examples of the 5 questions in action. And I selected a series of problems off of the first mock exam. And so instead of pausing the video, if you want to follow along on your calculator, what I would suggest is you might want to download the mock exam, print it out, and follow the instructions on it. This is a little bit intricate on this particular problem, and that's actually why I'm using it, because I don't know for a fact, but my guess is that many people look at this problem and they see that the data set is rather long and they blow it off as a result. And so normally I would never burn a problem off of a mock exam by doing it in a video, but in this case I thought that I would make an exception because it is a nice example, and hopefully it will resonate and help you to be successful at fielding these questions when you encounter them on the test. Now, we've been quite open in terms of talking about these 5 questions, and so it shouldn't be a surprise at all that we're going to be asking them. We want to show you these questions in action, and hopefully then you'll do much better at handling these when you actually get to the real questions on the test. So anyway, here's the mock exam, and this chart here is not exactly the data set. It shows roughly what the data set shows, but it covers a different period of time, and so it's not the same. But we're looking at data for West Coast gasoline prices, and the data set, if you scroll down here, you can see it covers from January of 2005 through March of 2009, and the X values are months after January of 2005, and the Y values are the price of a gallon of gas in cents. And we did not adjust for inflation when we did this, but anyway, we just assembled the data set. So the 5 questions start right here with number 33, and you can see that the data set is going to need to be keyed in. And so again, download the mock exam, print it out, and you can key it on off of that. I have it keyed into my calculator here, as you can see. And so the first thing is got to run the regression equation. So I'll do that. So we'll go to the stat menu as usual, and we'll go to the calc menu, and we're looking for linear regression, and the data is in list 1 and list 2, so we'll just run it. So right there you can see your regression equation, and as usual, it's always a good idea to jot those 4 numbers down so you have them. We're going to be asking about them, and so it's important to have them. I don't really have anything convenient to jot them on, so I'm just going to leave them on the screen here. Or actually, I'm going to save the regression equation as usual. So I'll go to the Y menu and stash it there. So there we go. We have the regression equation. Now the instructions on the exam, let's go back and take a look here. Question 33 says, what is the least squares line for the gasoline price data? Round all decimals to the thousandths place. Okay, well, if you go back and you look at those values, let's see that again. I'm just going to be lazy and run the regression again. It's just easier to do that rather than go motoring around inside the Y menu there. Okay, there we go. So the slope I would report as a 1.669. And the y-intercept I would report as 244.693 if everything is rounded properly. Let's see if that is a choice. I'm looking here at number 33, and it looks like letter B is the correct answer for that, so I'm going to go with it. At least on this version of the mock exam, it's correct. Next question is asking number 34, what is the practical significance of the slope? Okay. So we got to find the slope, and we got to figure out what the units of measure would be. Now, if you recall, when we look at a slope, yeah, I wanted the calculator there. The units of measure. We can leave this screen here for the moment. The slope was 1.669. We'd probably like it as a ratio, 1.669 over 1, and the numerator in this case would be response variable units, which would be cents per gallon, and the denominator would be explanatory variable units, which would be months. And so the proper interpretation of the slope in English, we're saying that It's 1.669 cents per month. It's a positive number, which indicates that the gas price is increasing at that rate. Let's look at the choices. Letter A doesn't look correct because the unit right there on the slope is $1.669, and that is not correct. The slope was in cents. Letter B says every month the price of gas increased 1.669 cents. I will go with that. That fits with what we understand to be the correct answer. So B is correct for 34, and you can read C and D on your own and figure out why they are wrong. Let's see, what's 35 asking? 35 is asking, what is the practical significance of the y-intercept? I think it would be a lot easier to understand the answer to this question if you actually look at the y-intercept graphically. And so I'm gonna look at that. Now, we had already prepared the regression equation for graphing, and so the only other thing we would need in this case would be a scatter plot of the data. And so I'll throw that in there as well. Let's see here. We're looking for, I actually have to go to the stat plot menu to do that. We are looking for plot number 1. We want a scatter plot, and we want it on list 1 and list 2. So there we go. And for a reasonable window size, I'll just do zoom 9 and see what we get. Boy, that's a pretty busy graph right there. Let's tidy it up a bit. So the x values, I think I would probably want to go just a little bit larger on that. I'm going to go from 0 to 60. I think that would be a good choice. You'll see in a bit. The scale, a scale of 5 would be adequate to cover that. The y minimum, I'll go from $1 to $5. Or, well, it's in cents actually, right? So we probably want to think about that. $1 is 100 cents. And so $5 would be 500 cents. And as far as the scale is concerned, let's go with a scale of 50. That's probably adequate. And so now if we graph that again, it's a little bit more refined. Now, I think it would be helpful to zoom in and look really closely in order to answer this question, because this is confusing to a lot of folks if they don't have experience with this. So I'm just going to do a quick box zoom on this. And let's see, where's my cursor? It's over there. I need to get the cursor over by the y-axis. There we go. Okay, that's cool. And maybe I'll go down just a little bit. Yeah. So I'll lock that down. It's probably too far. That's probably good enough. It's going to be a little distorted, but it'll cover what we want. Okay. So what you're seeing right here is the regression equation, and it's crossing the y-axis at one point. And that funny looking thing down there is actually a data value. And you can see that the y-intercept of the regression model is not the same as what the model says that the y-intercept is. And so, or what the data says that the y-intercept is, rather. So in other words, the model's version of the y-intercept and the data's version of the y-intercept are different. And so that's what this question is speaking to. And so when you read number 35 here, it says, oh, and that's the other thing. The coordinates of the y-intercept would be 0, 244.693. What does the 0 represent? It's months after January of 2005. So in other words, it is what the model says that the gas price was in January of 2005, as opposed to what the data says it was. And so I'm looking at this. It looks like it's letter B again. It looks like we're running into a string of B's here. According to the model, it is the price in cents per gallon of gasoline in January of 2005. I agree with that. That is correct. Okay, and so question 36 is saying, according to the regression model, what should the gas price be for August of 2009? So let's figure that, what we're being asked to do here. You'll notice that March of 2009, which is the third month, is 50. Now August is the 8th month, and so 8 would be 5 months after the 3rd month. And so in other words, the x value that you're actually being asked to input here would be 55. Okay, so here's what we want to do. Our window size has been jiggered a little bit. We need to fix that so we can actually see that x value in the window size, or the model won't cough up a value for us. So I'm going to change that back to the way we had it. I think we were going 0 to 60 before. And then on the y, scale of 5 is good. And then we were going from 100 to 500, if I recall. And so I think that's good. Let's take a look at that graph. Now we're being asked to use the model to predict the gas price in August. And we determined again that August of 2009 would be 5 months after March of 2009. So the x value would be 55. So you go here to second trace, and you select number 1, and you put in 55, and the model is coughing up 336.478. 336.478. Now I think we're going to round that to probably 1/10 of a cent. Let's go and see what the instructions say. Round your answer to the 10,000th place, i.e. the nearest 1/10 of a cent. Okay, so in other words, 4 places. Or well, yeah. So anyway, let's see, 336.5 cents, I would think. Let's take a look at what the exam offers. 336.5, that looks like letter D. So I'm going to go with that. Okay. Now 37 is asking you to scatter plot the gas price data and superimpose the regression equation. So we've been looking at that. We've been looking at that already. And it's asking us to judge which of the following would be true. So we need to mark all that are true. So in other words, the question may have more than one answer. And you can do that with certain multiple guess questions. I usually try to flag it when it's that way because otherwise it's kind of tricky. But anyway, let's see. A says, using the model to predict the price of gas for August of 2009 is an example of interpolation. Okay, well, let's chat about that for a second. If you look at a typical linear regression example, when you are making calculations within the bounds of the data set, that is called interpolation. And so you can see the data set is here, and you can see the vertical boundaries are these horizontal lines, and the horizontal boundaries are these vertical lines. And so as long as you stay within those lines, you're interpolating, but once you go outside of those lines, you're extrapolating. And so let's see if that's correct. It said using the model to predict the price of gasoline for August, that's interpolation. That's false, because the data set stopped. You can see this right here. It stopped in March. And so we're outside of the data set in order to make that prediction. And so that is not interpolation. That is extrapolation. Letter B says the linear regression model fits the gas price data well enough to be of use. I would disagree with that as well. We probably would want to look at the calculator to see that. Let's go back and take a look here. This is, I guess you could use this screen. I was going to go back and run the equation again to show you the correlation coefficient, which was low. It was like 0.41. But you can see with your own eyes when you look at this that this is a very nonlinear data set. I mean, we do have sort of a linear trend because it is generally increasing, but the data set is periodic. It has this up and down, up and down, up and down. That's not linear. And so that's why the correlation coefficient is so low, and that's why using the model to predict the gas price in August is kind of dumb, because it's just not a linear data set. You need some other kind of a model here. So I would not go with that one either. Letter C says, based on the combination of the regression equation graph with the scatter plot, one can see that the gas price is negatively correlated with time. So in other words, what that is saying is that when you look at this graph here, when you look at this graph here, that the slope of the regression line is generally negative, and I would disagree. It clearly has a positive slope. And so I'm going to disagree with C as well. I don't agree with that. D says the linear regression model accounts for more than 50% of the explained variation in the data set. that is asking for the coefficient of determination. And it's actually the square of the correlation coefficient. And we saw it on the screen a few minutes ago. Let's get it again just so you have it. Let me quit this. I'll just do the regression model real quick. What? I must have hit something wrong. Let's try that again. Let's quit that and let's try that again. Okay, calc. There we go. Okay. So I was right. You can see the correlation coefficient is 0.416. That's very low, not very linear. And the coefficient of determination, which is r squared right above it, is 0.173. Now what that means is that the amount, well, the months explain the variation in the y value. The model explains it about 17.3%. So in other words, it's not a good model. I could say that a little bit more elegantly. About 17.3% of the variation in y is accounted for by changing x. And so in other words, this is a poor model, as you saw, right? The screen showed it. And so I would disagree with D as well. It looks like E is the correct answer for 37. And then let's see, 38. That doesn't actually pertain directly to the model, so I will leave that for you. Anyway, I hope this has been helpful. The one other question that I did not ask in this particular series of examples was, given y, find x. We did given x, find y. That happened to be question number, let's see, that was number 36. Okay. In this particular situation, the given y, find x doesn't work very well, because if you go back and you look at the screen, if you were to draw a horizontal line at a particular level, let's look at the graph again. If you were to draw a horizontal line at a particular level, you would find that many x values correspond with certain y values. And so for that reason, it's really not fair to ask that in this case. It would be extra confusing, and so that's why I didn't ask it. Anyway, again, I hope this was helpful. Please click on the link for the next video. The next video is coming from chapter 5. And so this video here is the last one that covers material from the first exam. I thought you should know that.